Welcome back to the deep dive. AI, it's everywhere you look these days, even changing how we write code.
Mhm.
But what happens when you can't tell, I mean, really tell if a piece of code was written by, a person or an AI?
Mhm.
That's what we're diving into today.
Yeah.
And believe me, it gets pretty interesting.
You're absolutely right. With tools like, GitHub Copilot becoming more and more popular, I mean, this isn't just theoretical anymore. It has real implications, like for security,
Mhm.
education, even the legal world.
Exactly. So think about it. You're a developer and you're using one of these AI code assistants. It's a huge time saver, sure, but how can you be sure? I mean, how can you be sure that the code it's spitting out is secure? Or what if you're like a teacher trying to
Mhm.
grade student work? How do you know if a student actually wrote the code themselves,
It-
or if an AI did it for them?
These are the exact kind of challenges researchers are trying to address. And the research paper, the one we're looking at today, is this you, LLM? Recognizing AI written programs with multilingual code stylometry, it offers a fascinating new approach.
Okay, I'll admit the title sounds a bit intimidating, but stick with us. It's actually pretty straightforward. The researchers are basically trying to identify the unique fingerprint of AI generated code.
It's um it's similar to how each author has their own writing style.
Yeah.
Programmers, even when they're trying to write clean and efficient code, they leave behind these subtle stylistic clues, the way they use variables, their, formatting choices, even the comments they write, all of these contribute to their individual code stylometry.
So it's like a digital detective story where we're looking for those tiny inconsistencies that give away the AI's,
Right.
hand. But here's the catch. AI is getting really good at mimicking human code.
That's exactly the problem. Older detection methods were pretty basic. They could maybe tell if code was, AI generated, but only if it was written in one specific programming language. So if the AI was generating code in, say, Python, the detector, it might work, but switch to Java and it would be completely lost.
So we needed a more powerful tool, something that could handle the complexity of AI generated code, across multiple languages.
Right, precisely. And that's where this research takes a giant leap forward. They developed a new model that can analyze code written in 10 different programming languages all at once.
Wow, that's impressive. But how did they even train a model to do that? I mean, we're talking about vastly different languages here.
That's where the H-AIRosettaMP dataset comes in. Think of it as a massive library of code snippets, 121,247 to be exact, covering 10 of the most popular programming languages.
So they basically fed this model a ton of code, hoping it would learn to tell the difference between human and AI, right?
More than that, they used a really clever trick to make the AI's job even harder. They used code translation to create the AI generated code, making it, way harder for a detection system to pick up on simple patterns.
Wait, so they were intentionally trying to make the AI-generated code look more human? That's sneaky. But I guess that makes sense. If you want to build a really good detector, you have to, train it on the toughest possible examples.
Exactly. They even went a step further and made sure the data set was balanced for different programming tasks. So the AI couldn't just learn to identify what the code was, doing. It had to focus on the how.
So they forced it to look for those stylistic nuances, those fingerprints we talked about. Instead of just relying on, surface level clues, it sounds like they threw everything they could at this model.
And that's where the choice of AI model comes in. They didn't use just any AI. They used a transformer,
Well,
specifically one called Code T5 Plus.
okay, now we're getting into the, really technical stuff. I've heard about transformers, but honestly, they still sound a bit like science fiction to me. Can you break it down for us? What makes them so special?
Well, imagine trying to understand a sentence by just looking at each word individually. You might miss the overall meaning, right? That's how older AI models worked with code. They analyzed it piece by piece. But a transformer can process the entire code snippet at once, capturing the relationships between different, parts of the code.
So instead of just seeing individual words, it's understanding the entire sentence, the grammar, the nuances, the style.
Exactly. And that's what makes them so powerful for code stylometry. They can detect those subtle stylistic patterns that are so hard to spot otherwise.
And this is the first time a transformer has been used for this, specific task, right? So we're talking about cutting edge stuff here. What were the results? Did it actually work?
The results are pretty impressive. The new model achieved an average accuracy of 84.1% in identifying AI-written code across all 10 languages.
Wow. That's way better than anything we've seen
Yeah.
before, right? But 84.1%, that means it still got it wrong sometimes. What about those cases? What can we learn from them?
That's where things get even more interesting. The researchers found that the AI's accuracy varied depending on the language the code was originally translated from. They call this the provenance of the code.
Provenance. So it's like saying the AI's fingerprint detection skills are better with certain accents. That's fascinating. And it opens up a whole new set of questions, doesn't it?
It certainly does. For instance, could developers use this knowledge to intentionally longer AI-generated code, making it harder to, detect? Or could we use this provenance information to track the origins of code, even if it's been translated or modified? These are the kinds of questions researchers are just starting to explore. It's like, we've opened a door to a whole new world,
Yeah.
but we're not quite sure what we'll find on the other side.
It's both exciting and a little bit unsettling, right? I mean, if AI can write code that's practically indistinguishable from human code, what does that mean for the future of software development?
That's a big question, and honestly, we don't have all the answers yet. But this research gives us some valuable insights. For example, the fact that this new model is so accurate, that's encouraging. It means we're getting better at understanding the nuances of AI generated code.
So it's not just a hopeless race against increasingly sophisticated AI. We actually have a chance of staying ahead of the game.
I'd say so, but it's going to require ongoing research and collaboration. We need to keep pushing the boundaries of detection methods, anticipating the next moves of AI developers who are, let's be honest, also trying to make their code harder to detect.
It's a fascinating cat and mouse game, isn't it?
Yeah.
AI trying to write code that looks human, and researchers trying to develop even smarter ways to tell them apart. But you mentioned something earlier about the importance of openness in this research. Can you elaborate on that a bit?
Absolutely. One of the most remarkable things about this study is that they used only open source tools and data sets. This means anyone can access their data, replicate their experiments, and verify their findings.
So there's no black box here, no secret sauce.
Yeah.
That's a big deal, right? Especially in the world of AI, where a lot of the research happens, behind closed doors.
Exactly. Transparency and reproducibility, they're crucial for building trust in scientific findings. And it allows the entire research community to build upon this work, to refine the model, to find, new applications.
It's like a collective effort to understand and address the challenges posed by AI-generated code. But what about AI models that aren't open, like ChatGPT? How does this research apply to them?
That's a great question. And the researchers, they actually tackled that head on. They tested their model on a data set of Python code generated by, ChatGPT, which, as you mentioned, it's a bit of a closed system. We don't have full access to its training data or the details of how it works.
So it's a bit of a blind test then, like trying to crack a code without knowing the cipher. What happened? Did the model work?
Well, even without any specific training on ChatGPT's style, the model was able to identify its code with 72.8% accuracy.
72.8%. That's still pretty good,
Yeah.
considering it wasn't designed with ChatGPT in mind, but it's also a noticeable dip from the 84.1% accuracy it achieved on the open data set.
Right. And that difference in accuracy, it really highlights the importance of openness in AI research. Because ChatGPT is closed, we can only speculate about why the model's performance, dropped. It could be due to the specific way ChatGPT was trained, the type of code it generates, or even the prompts used to generate the code.
It's like trying to solve a mystery with only half the clues. You might get close to the answer, but you can't be entirely sure you've got it right.
Exactly. And this is why research like the one we're discussing today, which embraces openness and transparency, this is so vital. It allows us to fully understand the strengths and limitations of these, detection methods, and it paves the way for more robust and adaptable solutions in the future.
So it's not just about spotting AI-generated code. It's about creating a more transparent and trustworthy ecosystem for AI development as a whole.
Yeah.
But let's come back to the practical implications for a moment. If you're a developer using an AI code assistant, or a teacher trying to prevent cheating, what can you actually, do with this information?
That's where things get really interesting. The researchers, they didn't just develop a a detection model, they also explored the concept of provenance in more detail. Remember how we talked about how the AI's accuracy varied, depending on the original language of the code?
Yeah, the code accent idea,
Yeah.
that's one of the most fascinating parts of the paper.
Well, it turns out this provenance information could be a valuable tool for tracking the origins of code. Imagine being able to trace a piece of code back to its source, even if it's been translated or modified multiple times.
It's like having a digital breadcrumb trail for code. That can be incredibly useful for everything from security audits to intellectual property investigations. But could it also be used by someone trying to hide the fact that their code was, AI generated?
That's a possibility, and it's something we need to be mindful of as these technologies, evolve. It's like any tool; it can be used for good or for ill. The key is to understand its potential and to develop safeguards to prevent misuse.
It sounds like we're just scratching the surface here of what's possible with AI code detection and provenance tracking.
Yeah.
But before we get too carried away with the future, let's bring it back to you. Why should all this matter to someone who might not be a developer or a cybersecurity expert?
That's a great point. This isn't just about, technical details. It's about understanding the broader implications of AI on our lives. Think about it. Code is the foundation of the digital world. It powers everything from the apps on your phone to the systems that control our infrastructure.
So if AI is writing more and more of that code, we need to be aware of the potential risks and benefits.
Right.
It's like anything else. Powerful tools can be used for good or for bad.
Exactly. And this research, it gives us a glimpse into how we can start to navigate those challenges. It shows that we're not powerless in the face of rapidly evolving AI. We can develop tools and techniques to understand and manage these changes.
It's about, taking control of the technology,
Yeah.
not letting the technology control us. And it starts with asking the right questions, like the ones we've been exploring today. But I think there's one more, big question we haven't touched on yet.
I agree. We've talked about detecting AI generated code, but what about preventing it in the first place? Or even more intriguing, what if we intentionally wanted to create AI that could write code that's indistinguishable from a human's?
That's a fascinating thought. It's like turning the whole challenge, on its head. Instead of playing catch up with AI, we're setting the rules of the game.
Exactly. It would require a deep understanding of human coding styles, the ability to anticipate the nuances that make code look, human,
Mhm.
and perhaps even a touch of artistic flair.
It's a challenge that could push the boundaries of AI development and
Yeah.
force us to confront some fundamental questions about the nature of creativity and what it
Yeah.
means to write, good code.
It's a challenge worthy of a deep dive, wouldn't you say?
Absolutely. And on that note, we'll leave you with this final thought. If you were designing an AI that could write code, how would you try to make its style, indistinguishable from a human's? It's a question that's both, technical and philosophical. And it's one that will continue to shape the future of software development as AI becomes more and more, intertwined with our digital lives.
Until next time on the deep dive, keep questioning, keep learning, and keep coding.